Okay.
Okay. Hello, everyone. Welcome to another episode of Let's Discuss the Paper right after reading it. In a typical session, we choose a paper we want to read, we read it in 2 hours, and then we come back to discuss it. Today, we have two people, me and Yota. Yota, can you introduce yourself?
Hi, I'm Yota. I'm a research assistant in Japan.
Okay, so as for me, my name is Qian Chen, and I'm currently a PhD student at Monash University, Australia. So the paper we read today is by Law and Collins, published on Journal of Neuroscience 2 weeks ago. It's titled The Representational Similarity Between Visual Perception and Recent Perceptual History. Here, as the host for today, I'll first give a summary of the contents of this paper, and then we'll discuss any issues and questions we have with the paper. Okay, so for this paper, for the background of this paper, so in everyday life, as we go around in our environment, our brain will actively code the sensory input we receive and to create different representation of different types of external stimuli. And one way to investigate these kind of brain representations is to use the representational similarity analysis, which looks at the whole brain activity underlying the perception of different stimuli. For example, you can have a participant viewing a face and then have the participant to view a computer, and they will look at to compare the representational similarity of people's brain activity when they view these different objects. And the assumption is that they will find low similarity for brain activities when they are viewing different objects. In this study, the authors plans to use the RSA, which is representational similarity, to investigate the neural mechanism of a perceptual phenomenon called serial dependence, which is basically the influence of your recent past perception on your current experience. So mainly using RSA, they want to know whether the brain representations for seeing different visual objects are similar if these perceptions are all preceded by the same past. So if they share the common past, then they will have some kind of similarities. To investigate this question, they devised a behavioral task accompanied with EEG data collection. So for the behavioral task, they have the participants to view an image of either a face, a car, or a house. And then they ask the participant to report the object category. And then after doing that, they show them a kind of morph image, which is a kind of bistable stimulus that combines features of the objects they just saw and the features of another object type. For example, if they have the participant to view a face before, then the morph image they're seeing right now would be a combination of, let's say, face features and house features, or face feature and car features. And after participants see this morph image, again, they will ask the participant what category they think the morph image belongs to, a house, a car, or a face. And while they are doing this kind of image viewing and reporting task, they collect the EEG, they measure brain activity of the participants using EEG. So with these methods, they had two sets of results. One is their behavioral results, and the other is their results from analyzing the EEG data. For the behavioral, the main thing they want to know is the serial dependence actually happened with their manipulation. Here, their definition of the serial dependence in the task is that if the participant reported a morph image as an object that they have just viewed, then serial dependence happened. For example, if they have the participant to see a face, like an unambiguous face, and then they have the participant to see a morph image of combining face and car, and the participant reported that morph image as a face, then it means their previous experience of the face has shaped their current perception of the morph. And that is serial dependence. And what they found was that across all the trials, like the 1,600 trials they perform on each participant, serial dependence happened at the rate slightly but significantly above chance. And because serial dependence happened, they can proceed with their neural data analysis to investigate the underlying mechanism for serial dependence. And as they proposed in the intro, their analysis will be representational similarity analysis, and they propose 3 different analyses to fully understand the neural mechanism. So the first RSA analysis, the goal of it is to confirm that the object category information is reflected in the brain activity. To achieve this, what they did was to compare the representational similarity on brain activity when the participants are viewing the unambiguous objects of face, cars, and house. And what they found was that the brain activity for the same object category are higher in representational similarity compared to brain activity underlying different object categories. And this reflects that the object category information has been represented in the brain. And this kind of similarity pattern was mainly driven by occipital parietal region around 200 millisecond post-stimulus onset. All right, and now that they know that, okay, object category is represented in the brain, then they can proceed to understand whether you can find paths in the current experience. So to do this, they run RSA for morph images for brain activity underlying morph images that are preceded by the same object versus morph images preceded by a different object. And what they found was that they had a significantly higher representational similarity for morphs preceded by the same objects and compared to those preceded by different objects. Although with one exception, where morphs preceded by houses and faces are actually at the same level, same level of similarity than the morph images preceded by same objects. But anyways, overall, this is an evidence for serial dependence where they found a trace of the past in the current experience. And this kind of differences is mainly driven by the frontal lobe at around 400 to 800 milliseconds after stimulus onset. Now, the second analysis shows that past perception is coded in brain representation for the current perception. The next question is that, is there any difference in the way that our brain codes the past perception during the perception is actually happening versus when it is coded as a trace in the current perception? To answer this question, they run another RSA comparing brain activity of the past compared to brain activity of the present. And what they found was that the trace of the past in the current response is completely different from when that past perception was happening. So in summary, they found that past perception shapes current experience as supported by the neural trace of the past that can be found in the activity of the present experience. Okay.
Thank you.
Any comments?
Yeah, comments. So first of all, new RSA analysis before reading this paper. And also, when I skimmed through the paper, the task sounded simple. So I thought that I could understand this paper easily. But the RSA analysis part was not that easy to understand, to be honest. And the reason is that, as you explained in the summary, they have 3 different RSA. The first one is really simple, I think. It's just a standard RSA, I think. The second one was, I think, was the most difficult for me to understand. The reason is that when I read the abstract, I thought that they did RSA analysis by comparing the current versus the past stimulus, which I think corresponds to maybe or somehow related to RSA analysis or the third RSA analysis. But the second one was completely different, right? So they do take the correlation of current activities while considering what was the past stimulus, right? And that part was, I did not have any idea why they did that. So it was difficult, but I now could understand why they did that. So, which is good.
Okay. Okay. Cool.
Yeah.
Anything else?
Yeah, so so what they basically said is that this serial dependence cannot be just an reactivation of the same process, right? While seeing or the reactivation of the past experience during seeing something different. And yeah, that's interesting point. But at the same time, in the discussion, they mentioned that maybe if we have more strong serial dependence effect in behavior by changing experimental tasks, then we may be able to see strong activations, which suggests that it's just reactivation, not a completely different mechanism. So I think that's important point.
Yeah.
I
also noticed the same thing as well, because in their results, their behavioral results was 6% of serial dependence. I'm not exactly sure what that entails, but my guess it's 6% above chance. Of course, if you want to look at the effect size, you need to look at the past literature in this field of research for serial dependence. But it looks from a naive point of view, it's not the strongest effect size. And I was also thinking maybe the reason why their serial dependence effect was weak because they only use one bag to shape the current perception, right? But if they have they maybe let's say they repeat the same stimulus for 1 and then 2 and then 3 times, maybe they will have an increasingly strong serial dependence effect on the current perception. And maybe with increased repetitions, they may be able to have stronger serial dependence and also see whether it is a reactivation or not.
Yeah. Another point is that or this part I could not understand, but in the discussion they mentioned that what they found is just regarding RSA, the second RSA analysis, saying that they found the impact of the past stimulus on the current activity. And in the discussion, they say that this cannot be explained just by the a residual of the past stimulus, or what they explain the discussion is that I need to check the paper to yeah, what they said is yeah, this part. Yeah, what they said is that where? Yeah, so that the response to the previously seen stimulus simply lingers for an extended period of time and spills over into the next trial. This is, I think, reasonable alternative explanation why we see the effect of the past stimulus on the current activity. But they said that this alternative explanation is not, or is kind of invalidated by some analysis, but I could not find which analysis invalidate this. Does it?
Can you point me to the exact places where they bring this idea up?
So it's page 7, and I think the first paragraph in page 7, it's around the middle of the first paragraph.
Okay.
So the first paragraph starts with, our results show that the temporal aspect is not like running blah, 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 blah. And then, yeah, what they said is that this analysis examining representational similarity between object representations and their trace on subsequent representations also also addresses a potential alternative explanation for our results, that the response to be.
I think that points to the third RSA they ran, because they found no similarity between the present and the past. So the past, when the actual unambiguous phase was being seen, compared to when the participant is seeing the morph image and reported it as a phase, that the neural activity for seeing the actual phase and the phase shaping the current morph image is completely different. So you can't say it's just a lingering of the previous phase activity because it has been transformed to something else. I think that's what they're trying to say.
Okay. I see.
It's not some kind of, I feel like if it's like a lingering thing, it would feel more like a after image of some sort. If, phenomenologically speaking.
Yeah. I mean, that's most intuitive, at least to me. Some effects are still going, and then that affect the, following processing. Yeah, so I was thinking then, what's the alternative mechanism?
Do you remember a paper we read before by King and Weiner? Weiner. It was called "The Human Brain Encodes a Chronicle of Visual Events at Each Instant of Time Through Multiplexing the Traveling Waves."
Yeah,
anyways,
I remember which one.
Yeah.
It was, but I forgot the content. I remember that the analysis or the task was difficult to understand or something.
Mm.
Yeah, I remember that paper. We read that. So you are
Yes.
saying that the paper is somehow related to this paper, or?
Yeah, so here that paper suggests at every moment our neural activity can represent multiple stimulus that are activated. So if you see stimulus 1, 2, and then 3, and then you measure the neural activity as stimulus 3, then you'll find how do I say this? The neural trace for stimulus 1 and 2 and 3. So they are a combination of the 3 together.
I see. Mm.
But then they also did the modeling on the results, and they found some kind of feedback loop, some updates in the feedback loop that facilitate this kind of representation. But I don't know how it exactly relates to the current paper, but if the way our brain handles multiple stimuli is by sending update signals in the feedback loop rather than just, have one waves that is like the multiplication of the 3 different waves, then it probably does make sense that in the current paper that we are reading, the trace of the past is not a reactivation, right? It could be, a new update signal of some sort.
I see. Mm.
Yeah.
I see. I see. Yeah. Yeah, but of course, they used EEG in this paper. So I'm not sure whether we can do any, network analysis to see whether the recurrent interaction is important to keep updated the past stimulus information.
Yeah.
Yeah. Other things, or by the way, do you have anything to say? If so, you can, go ahead.
Yeah, so I think my another point is also pretty related. Maybe how do I say this? I feel like it is possible that even further back has an impact on the present. And one way to look at this is to how do I say this? Modify their task to make it like look at face, look at house, and then a morph image of face, house, and cars. And then instead of asking participant to give one description, report just one category, you ask the participant to rate to what extent do you believe this thing, morph image, belongs to each category. Like how confident you are it is a house, how confident you are it is a car, and then how confident you are it is a face. And using a more graded behavioral report, you may and extend the influence to further back, you may be able to have richer results. But it could be messier because the current simple design already yielded a moderate effect size only, according to them.
Yeah. So, again, I expect that, longer past experience will have less impact than the recent past experience. So, as you mentioned, effect size or the effect of the experience is just too weak, and we can't just detect that. Yeah, but that's interesting, and I think this in this experiment they present one image for 300 milliseconds, right? And the interval was how long? Do you know?
They didn't give too much detail for the task, actually.
Yeah, Yeah, neither do I. But if we do something like that, then the experimental design is almost the same as the paper you mentioned, the paper we read, the multiplex, right? Because the paper, they presented the image like a continuously, and then see the effect of the past. And yeah. So I see. Another thing, maybe. So in this study, they use the behavioral data just to find which category or which image can, or which image is face, or which image is house, which image is cars, right? To group images into 3, right? Or not 3, not 6. The mix of 2 images. We need.
Yeah. So purely face, purely house, purely car, and then face car, face house, car house. So that's 6.
Yeah. So what I want to say is that this RSA, when Krigesgotet introduced the RSA analysis, the purpose is to connect the behavioral data, neural data, and the model. But here, what they're doing is just seeing the neural activity.
So they didn't subset the trials that in which there actually was some serial dependence in the behavioral reports. They just group everything together and then just subset them based on trial type rather than whether serial dependence actually happened in the trial, right?
Yeah, so I was wondering whether it's possible to, link the behavioral data and neural activity in terms of similarity matrix. And also, maybe, but I don't know. Modeling part is missing in a sense. No. But I don't know what kind of model can explain this. So, and also the finding itself is interesting. So the authors just didn't need to include the modeling part in this paper. Yeah, I mean, I like this paper, as we may discuss in the previous episode. Now it's doing quantum cognition stuff, and as Chan Shen, mentioned before reading this paper, this sounds relevant to quantum cognition. I don't know what kind of explanation can possible in terms of quantum cognition, but what we know is that from this paper is that the context, the past experience is important for the not experience, just the brain activity, but experience as well, because they did check the serial dependence behavioral data. So, yeah, I need to think a little bit about that future direction of this paper. Do you have any idea, or just a comment or anything is fine?
I'm thinking, but at this point nothing much comes to mind, because now's color similarity experiment, which is one of his one of the kind of his evidence for quantum cognition, Folia. What they look at in color similarity is not how seeing red shapes green or seeing green shapes red, but seeing red first and green second shapes the similarity, perceived similarity between the two. So that's the, minor difference. I feel like, yeah, if you want to propose something about quantum cognition, you probably want to think about how quantum cognition explanation offers a better explanation to, serial dependence, predictive coding, rather than, you can use these as evidence, but you also need to be careful because serial dependence and predictive coding may offer a simpler explanation than quantum cognition. So I also thought about maybe the similarity findings you have may be different in a case when, your experience can be explained by Bayesian processes. I don't know how the Bayesian processes. I haven't figured out how Bayesian processes can explain this serial dependence, but quantum cognition offers a. Okay, where was I? So the similarity pattern for experiences that can be explained by Bayesian processes is different from the similarity pattern you have for brain experience that's not explained by Bayesian analysis, Bayesian processes, and that is when quantum cognition jumps in. But I don't know.
Yeah. Yeah, I totally agree with you. We already have, explanation like a serial dependence, and everyone, happy with that. So why quantum cognition?
So yeah, it's better to look for maybe something that is, irregular or unexplainable by serial dependence, and quantum cognition can explain both this and that would be really good, right?
Yeah, that's the best scenario, but I'm not sure whether it's possible or not. We'll see. Yeah. Okay. Anything else, Chanshin?
Not for me.
Okay, so let's wrap up here. See you next week. Bye-bye.
Bye-bye.